Well, today I'm working on this Craftsman DGT6000 deluxe garden tractor, and it is quite a unit. It's got 24-inch tires, heavy duty, hydrostatic transmission. I'm working on it for a neighbor, mainly for running and driving issues, but I did find some other preventative maintenance items along the way, and one of those is this fuel tank, which has some cracks in it that you can see right here. This was made by AYP, or American Yard Products. They made Craftsman and also Husqvarna. I've got a Husqvarna with the same issue. They've got a sort of a sight glass on the left side next to the seat here where you can see your fuel level. That's where the UV is able to get to the plastic, and over time it deteriorates it, becomes a little brittle, and you end up with these cracks. This one is savable, but others I've seen actually have holes in them. And the problem is you can't buy these anymore. You haven't been able to buy them for quite a long time. They're unobtainium, but you can find them used every once in a while. On eBay, they go for like 300 bucks. So you really have a couple options. You can live with it until it dies. You can replace it with a much smaller unit that changes where you fill it up. You end up filling it up under the seat, or you can try to repair it. The difficulty with repairing these is that they are HDPE, or high density polyethylene. Now that's a great plastic. It's super tough, unfortunately not UV resistant enough. But the problem with HDPE is that it's notoriously difficult to bond with. You actually can use some specialty adhesives, specifically for LSE plastics, or low surface energy, which is what this is considered. But they're expensive, and I didn't want to wait for shipping, and I actually already have a solution that I've used on my own Husqvarna tank in the past, which works pretty well. And that is this stuff. This is West Systems G-Flex Epoxy, toughened epoxy. And this is an epoxy resin that you can use with fiberglass cloth, which is what I'm going to do here today. What's nice about it is it has a little bit of flex to it. It doesn't get super hard and brittle, and it actually has pretty good adherence properties on plastics. They're difficult to bond to like this as long as you rough them up. So as a recovering former boat owner, I've done plenty of repairs with fiberglass and epoxy, and it can work really well. This is a quick and dirty video today. I can't get into every detail. One thing that cannot be dirty though is cleanliness around the area you're going to bond to. It has to be absolutely pristine. So for that, I generally turn to brake parts cleaner. I want to clean it off initially before I start roughing it up, because I don't want to obviously grind any grime down into the plastic. So I'm just going to spray it down. Sure, I'll get comments about all the reasons that I'm doing everything wrong here, but I just want to get the surface really clean in the area that I'm about to rough up. And some of this stuff, you know, is already embedded pretty deeply. I don't know that I can get that off just with a paper towel, but I'm going to try to get everything off the surface that I can, just as a starting point. Next, for the epoxy to adhere well, it does best if there's a mechanical bite. That's true of most adhesives and paints. So I'm actually going to just use this 60 grit, pretty abrasive sandpaper. It's nothing special. I'm not going to be wet sanding, so it's just a dry style sandpaper, and I'm just going to be roughing up all around this area. Now, one thing to realize is that as the sun got to this material and caused the cracks, it also caused it to raise up a bit, and I'll do a close-up shortly. So I'm just going to kind of go in orbits around the repaired area, or the area to be repaired. And then I'll come through and sand the actual area that needs to be repaired, but I don't want to just start going back and forth honing it, because I don't want to thin this area where the cracks already exist, and I also don't want to bust them through. Got to be a little bit careful in this phase while also getting it nice and roughed up. So I'll bring you back once I'm happy with the surface roughness here. One of the things that's nice about HDPE is that sanding works really well. You can see like a dust comes off of it, almost like you're sanding wood or something like that. And that's compared to other plastics that get kind of stringy, and it's like you're smearing plastic around when you try to sand them. You'll get little like hairs and fibers that raise up. Not the case with HDPE, which is the same basis for UHMW, or ultra high molecular weight plastic. That whole family, I guess you would call it, is very like machinable. You can shear off things rather than just have it smear around. So it's sanded and roughened to my liking, and I sanded way outside of the area I intend to repair, because the worst case scenario would be having a well bonded repair that terminates onto some untouched, brand new, super smooth, almost glassy plastic. It starts peeling up there. Well, it's more likely to keep on peeling the rest of the way. So went way outside of the area that I actually intend to repair. I'm gonna give it a final clean. Again, brake parts cleaner, say what you will, but also acetone, any number of other cleaners would also do it, as long as it doesn't leave any residue. Fortunately, I know from experience, that brake parts cleaner actually does not attack this kind of plastic. I guess that's another main advantage of HDPE, is its chemical tolerance, and I'm sure that's why it was chosen for a gas tank. And yes, I know I should have my gloves on. In fact, I'm going to put gloves on in just a moment, but this is kind of the last moments of being clean myself before getting into the epoxy, and I just want to make triple sure that everything on my surface is extra, extra, extra clean. So there it is. I will put on my gloves now. We'll begin the process of actually using the epoxy. I've had this sitting outside. I've used this for years. It has excellent shelf life. It is good if you warm it up first. In fact, you can even put this stuff into separate cups and heat them up, either in dunking into a hot water. You can have like a bucket of hot water and you put these inside there. You can even microwave little cups of it. If you heat up the resin and the hardener, they will become much thinner, and that can be easier to work with. They start out fairly thick, and normally that's okay, but if you're having trouble getting it into your cloth weave, or you're trying to work in an area where you need a bit of flowability, try heating it up first. It is a hot, hot day. I've got the door shut so that it's not messing up the white balance, and I'm already breaking gloves. Why don't I bring you back once I'm suited up and ready to go? This is the cloth I'll be using. Something critical to know that I didn't know until actually fairly recently is that you cannot use epoxy with glass mat. That is the strands of fibers that are all different directions. Those strands are actually bonded together for the purposes of holding the mat together, and they're bonded with a chemical that requires styrene to break that bond. And epoxy doesn't have styrene, whereas polyester resin does. So if you use epoxy on that fiberglass mat, that chemical that bonds those together will still be present, whereas if you use polyester, it will remove it. However, epoxy works great on regular old fiberglass cloth. And this stuff is actually, it's called tape. They call it a repair tape. I like it just because I only have to cut one dimension versus cutting out a full square. So I'm actually just going to trim off the end here to have a clean end. And I'll put a couple layers of this cloth tape down. Man, these scissors are just junk. I'm going to have to swap out to different scissors. I had no idea they were this bad. Be right back. I never thought I would get so excited about a pair of long blade scissors, but these come in so handy for so many different things. I'm glad that I bought them. So let's cut off a nice clean edge in one swipe if we can. Oh my gosh, it's like having a paper cutter. Beautiful. The less you let this come apart, the easier the job goes. So we need it to be about that long. I'm going way outside the repair area. It's not critical that I pick the exact right length, but I'm trying to size it to the repair. And I'm going to do 3 of these at least. I'm thinking one down next to it, and then one on top of both. Preliminarily, that's my plan. So I'll set these over to the side, and then we'll get to mixing up some actual epoxy resin. If you've ever done epoxy work or fiberglass work in general, you know there's sort of a calm before the storm as you're setting things up and before you start actually mixing up product. Once you do that, it's like all your best intentions fall apart. Maybe the really experienced guys don't have this issue, but generally I get everything set up with the best laid plan, and then it just takes some sticky fingers accidentally touching the wrong thing. Things start getting wild. So I'm not going to worry about it too much if that happens. Part of it is just rolling with that sort of stuff because it is inevitable, at least in my experience. All right, I've got my chip brush. I've got my 3 sections of fiberglass cloth, and I went and got one of these just disposable mixing bowls because I'm at the end of the bottles and they're not exactly the same level anymore, and I want to get this mixed correctly. So we'll get the dog hair out of there. It's the fun of dog life. And pull these caps out. I've been religiously keeping them separate for all the time I've owned these bottles. You would not want to mix up those caps unless you wanted to permanently seal the bottle. But this should be the last day that I use this stuff. So I'm going to be a little less careful than usual. And I think I might just go for broke and make a full batch. All right, so let's look at some freedom units or metric milliliters, whichever. I basically just want to see how much resin I have, and then I'll match that much with hardener, even though I've got a little bit more hardener in the bottle than I do resin. The idea with this stuff is you just do a 1-to-1 mixture, and I usually just eyeball it, and over time, theoretically, your bottles should be at the same level if you've been doing it right. Okay, we've got 2 ounces of resin. That works out nicely. So we'll drop in 2 ounces of hardener. I've got some wooden sticks to stir it up with. I've got my chip brush ready. I've also got some parchment paper that I can use to lay down on top of everything and do the final smoothing if I like. Parchment should not stick, but of course your mileage may vary. So I'm doing 4 ounces total. This is a decent sized batch, so it could get hot, just something to keep in mind. Looking at it now, this is more than I needed to do, but this is going to get her done, so that's all that really matters. Oh, epoxy can be difficult. I'm better at it than I used to be, still not an expert. So you got to watch out for not doing too little or too much of everything. You can see I added hardener to the resin. That way you're not starting with a ratio of 90 parts hardener to 1 part resin. You'd rather go the other direction and creep up on the 1-to-1 ratio. You also don't want to overstir, which I'm probably at that level, but you don't want to understir because then you might have hardening issues. It's fun stuff, but it is quality adhesive. It really does amazing things. And cleanliness, of course, is important. So you just throw things down wherever you can. Notice the whole sheet here. I don't trust myself with great cleanliness, so I made preparations ahead of time. All right, let's paint this whole area. It's okay if resin goes outside of the area of repair. It's very not okay if you don't apply to the whole area. So this is going to be more than needed. I'm also not worrying. I'm not building a boat or an airplane here. I'm not super concerned about the weight or the cost effectiveness of the repair. However, that said, an overly resined repair is not a strong repair. Your strength is typically achieved with something close to the minimum amount of resin you need to completely wet out and soak your fiberglass fibers. So yeah, there's another one of those balances. You don't want to have too little, but too much is not necessarily better. Okay, here we go. So part 1, I'm going to go all the way to the far edge, and I can actually wrap it around, and I can kind of pull. The nice thing about this cloth is you can kind of like pull it, and it'll go around corners for you if you ask it nicely. Okay, next one. Not seeking perfection. That takes way too long. Looks like they are going to overlap initially, these first two. It's because I don't need the full width of them side by side. And then we will do a bunch more on top of there for a center layer of cloth. I'm not painting, I'm trying to blob it on there because when I start painting, that starts pulling the glass. That's where you start pulling it apart. And things can get really difficult from there. I'm making sure that it's very, very saturated. Probably have the opposite problem of it being overly full. Okay, so this is effectively right over the main area that had the problem. So let's see if we can blot this in. I mean, it's pretty obvious when you're completely soaked. If you do a lot of layers all at once, it won't be as obvious. You can have air trapped, air inclusion down in the laminate somewhere. With this few of layers though, that's not really a concern. And getting the edges down can be tricky sometimes. I used to worry about all these little hairs hanging off. I don't now. Once it hardens, I can treat it like metal and like literally grind that stuff off. So yeah, I'm not gonna worry about that at all. And that's going nicely. Okay, I don't want to mess with it too much. I do want to go past the cloth though. I'm definitely on the verge of fixing it till it's broken. It's kind of my signature move. This one looks like I can get away with, nope, see, I shouldn't have touched that. What did I say? Yeah, I'm gonna leave those right there and deal with them later. For S's and G's, I want to try using some parchment paper to lay on top, see if I can really smooth it down and get any little air bubbles out of there. Leave it in the comments. Is this a good idea or a bad idea? And I'm not known as a baker, so I don't remember. Is there a smooth side and a waxy side? I guess not. I think parchment is just the same on both sides. So I'm going to lay this over here. Just kind of wrap it around. And now I can literally use like my hands and a cloth. And I can push it down, you know, physically push it down. Not just with the brush bristles, but with a bit more force. And now I'm really working that resin all through the cloth. Theoretically, this doesn't stick. Do we believe that? I think I have definitely too much resin. I could probably put another layer of cloth on there. So just got to basically get the edges down. And if the edge is down, if you're in the sort of the center of your laminate, looks like the stuff will come off fairly well. So, I don't know if that was necessary or not, but basically with that done, I feel confident that I got the resin worked through every little bit of the cloth. That said, there's going to be little touch-ups on the edges where I just kind of pulled it up a little bit, and that's okay. I can do that with my brush. All right, I'll bring you back when this is getting cured or is completely cured, or once I've decided to keep on going with what I'm doing right now and I've messed everything up. Look for that next. All right, so I couldn't resist my own nature and I did put another layer on, and in the end I got away with it, or I had good intuitions, however much credit I want to give myself. And I used parchment successfully to basically push that resin through to the new layer. You gotta know when to hold 'em. Know when to fold 'em. Know when to walk away. Know when you're done. You never apply more resin. Waiting, setting up already. There'll be time enough to overthink when the curing's done. Yeah, I wouldn't say I'm an expert lyricist nor fiberglass repair person. There probably are experts out there that are just like shaking their heads right now. I mean, I hope there are. That would be I would take that as a badge of honor, that anyone is still watching that actually knows what they're doing. And I hope, like hell, that those people leave some tips for the rest of us. So go ahead and leave a comment if you've done this sort of stuff professionally or even just successfully. I'd love to hear from your experience, but I don't know, I give myself about a B+ in general for this sort of work. All right, know when to walk away, know when to run. This is getting hot. I'm gonna put it someplace that it's allowed to spontaneously combust if it wants to. I obviously used way more than I needed to, but you know what? We were at the end of the life of those bottles anyways. Gotten lots of good life out of them. I've been storing a couple ounces for months now, so I'll get new bottles. That's no big deal, and I'm totally happy with the repair. This one is gonna go into the success bucket, and that's always a good day. Just over here cleaning up my scissors. Got a little bit of epoxy on them from a last minute trim that I said I wouldn't do to some cloth that was kind of bugging me. But anyways, I needed to clean these off quickly, and what it made me realize is that I didn't have my normal cup of vinegar around. That's something I normally do. I learned that when I was doing acroglass. Acroglass is typically used for like bedding rifles or doing other sorts of repair work. And yeah, vinegar does a great job of cleaning up uncured epoxy Once it's cured, vinegar is not going to touch it. Acetone's probably not going to touch it. You got to get some pretty serious stuff, probably with some ketones, I'm not sure, that will break into truly cured epoxy. But you can use acetone for quite a while past most other chemicals to clean it up. But if you want something simple that's low on the danger scale and easier on your hands, just get a cup of vinegar and some cloth out so you're ready to do cleanup. Learn from my mistakes. Well, I feel like Bob Ross with my painter's palette here, but I did do just a little bit of cleanup using my flap disc around the edges just to get anything that wasn't completely glued down and flush with the surface. When I was laying this up, I mentioned that I was going to let some of those whiskers just go wild off the side, not worry about them. When I came to remove them today, even if they were kind of glued down to the raw plastic, they peeled right up off of the HDPE, which is expected because it just has horrible adhesion. But when I kept on pulling them and I got to the areas that I had sanded and cleaned really well, they just stopped. I mean, the adhesion was really, really good. So that tells me the rest of this repair also has good adhesion to the plastic substrate below it. I just used the flap disc to basically do a little bit of a sand around the edges for those areas where they go from unglued to being glued. And now the last thing I want to do is a paint job, because keep in mind this G-Flex epoxy is not inherently UV resistant, and there's still this window that's going to be exposed for where you could originally see the fuel level. So the sun's going to be able to get to that area. I want to make sure this doesn't degrade over time just like the original plastic. So I'm going to sand this up and just apply a regular spray paint to give it that extra UV resistance. All right, painting's complete, and in fact, this repair is done. But I did leave out a couple of important steps that I'll share now. So whenever you're painting on top of epoxy, first you need to completely let the epoxy cure. And then, and only once it's completely cured, you'll want to do a hot water and soap wash down, and that can be hand soap or dish soap, it doesn't really matter, but you need hot water and soap and a scrub to get rid of what's called the amine blush. And most epoxies, not all, but most epoxies during their curing process are going to secrete this material to the surface called the amine blush. And it's kind of like a wax that will prevent further coatings from sticking to it. So it comes off easily, but you don't want to miss that step. So once you've done the hot water and soapy scrub to get the amine blush off, then and only then would you want to move on to sanding. And I used like a sanding sponge. I think I already threw it away, but basically you want to rough up the entire surface so that you can promote a good mechanical bond of the top coat and not rely on any sort of chemical bond. In fact, you probably won't get any because of the inert nature of an epoxy that's cured. So a good mechanical bond by roughing up the surface. You need to also make sure that you wash that off and clean out all the dust, out of all the crevices before you move on to painting. For that, you can use like alcohol. I wouldn't use like an acetone or anything more harsh on a freshly cured epoxy surface, but alcohol should be fine, or just a soapy water scrub. But you need to get it very dry, and then it's just like painting, wood or metal or concrete or stucco. It doesn't matter. You're just painting at this point. It doesn't matter that it's an epoxy surface that you're painting. For the paint, that does kind of matter. I chose this Rust-Oleum Painter's Touch 2X Ultra Cover Paint and Primer Satin Charcoal. So the reasons I chose this: A, says right on it, also bonds to plastic. It also has really good UV resistance. By virtue of it being a dark color, those are the best UV resistant paints. You can use a clear, but a clear is just going to have a UV inhibitor in it. Actually, some of them don't. But if you get a clear coat that's meant for a automotive application, let's say, that has UV protection, it's going to have a UV inhibitor. That's going to slow the UV, but it's not going to stop it. Dark paints can actually stop the UV from getting to the substrate. You could also use like a silver or a metallic paint. Those actually reflect the UV, which is pretty effective as well, but they're more likely to flake off. And so a dark paint, in my case, was the way to go. You're never going to be able to see the fuel level, even with the epoxy repair. We were already at the point where we weren't able to see through it anymore. So putting a dark paint on there doesn't really make much of a difference there. So this should give it long-lasting protection from the sun, which is what the original problem was. In this case, the paint's protecting the epoxy. The epoxy is holding together the plastic that was there. We should be good to use this tank for many years into the future. So if you've got this sort of situation and you're working on a tank like this, I hope this was helpful to you. If it was, do me a favor and hit that like button. It will help YouTube promote this video to the 2 or 3 other people in the world that have the same problem we do. But I sure would appreciate it. And if you have any questions, go ahead and put them in the comments. I'm happy to to clarify anything I said here or answer questions to the extent of my ability. But I'm going to put this back onto the garden tractor, fill it with gas, do my final checks and tests, but I think this is going to work out pretty well. So thanks a lot for watching, and we'll see you in the next one.